All right, this video covers geometric sequences 2. Some of the information that you need to do this particular practice set is in the geometric sequences 1 video, so you might want to go back and look at that and even practice those ahead of time. I'm going to get you prepared for this. Hopefully you'll pause for just a moment to set up your notes like I have mine set up. I have my title up here at the top, and I have how are multiplication patterns shortcutted as my big question. And that has everything to do with what we'll explore here in just a minute, which are exponents. And so geometric sequences are something that are akin to exponential functions, which you'll study in your first investigation. So go ahead and pause and write that stuff down, and then we'll jump into our first problem here. So I have a1 equals negative 14 over 3. AI equals 3 halves times AI minus 1. And so the first thing we need to do is learn how to read this bizarre stuff here. So a1 equals negative 14 over 3. It's referring to a sequence. And so this term right here tells you that the sequence, starts with the number negative 14 over 3. A1 equals negative 14 over 3 says something really specific. It just says it in a math language. It says this sequence starts with the number negative 14 over 3. This next one is a little bit more difficult to parse out. Whoops, I meant to get a highlighter there. So when I look at this one here, it's telling me something a little bit different. And that different thing that it's trying to tell me is this. So if I want to know some term in the sequence, that's AI, and I don't know which term, it's the number I, it's a variable, so it's just saying some term in the sequence is equal to 3 halves times, now let's look at this closely. If I have AI here, and then AI minus 1, this is the term before AI. And so that basically says to find some term in the sequence, it's equal to 3 halves times the last term in the sequence. And so that's what this setup tells you. It says, hey, this sequence starts at negative 14 thirds, and then to break it all down, this basically means multiply by 3 halves each time. Okay, so we're going to take a diversion here, and this diversion is going to explain the shortcut that we're going to do later, so hopefully you can get a clear idea about what's going on. And so I'm going to go ahead and start trying to write out this sequence. I'm going to write A1, A2, A3, A4, and we're going to notice some stuff. So A1 I know is negative 14 over 3, because it says it starts at negative 14 thirds. Now to find A2, I need to multiply by 3 halves each time. So I'm going to take negative 14 thirds times 3 halves, and that's going to give me negative 14 times 3 is negative 30 minus 12, so that's negative 42, and 3 times 2 is 6. Okay, to get to the third term, I'm going to have to multiply by 3 halves again, so let's go ahead and do it again. So negative 42 times 3 is negative 120, and then 3 times 2 is 6, so it's negative 126. And 6 times 2 is 12. And so I could be reducing these fractions. In fact, I probably should. But I'm going to go ahead and proceed here just because it's getting a little bit easier to look at. So if I want to get to the third term of this sequence, what I want to notice is, whoops, and I'll write this in a slightly different color. To find the third term, multiply by 3 halves, 1 time, 2 times, so 2 times. And the most important part of what I've written down here is to find the third term You have to multiply 2 times. And so the big idea that is lying underneath this is that we can shortcut this whole process in the following way. If I know that I'm looking for, and in this term I'm looking for A3, I know that the sequence starts at negative 14 over 3. And then I know that I'm going to multiply by 3 halves. And the question is, to get to the third term, how many times do you have to multiply by 3 halves? And the answer is 2 times. And how do you multiply by 3 halves more than once? Well, you raise it to the power of 2. Remember that an exponent literally means multiply by the number 3 halves this many times. So it says multiply by 3 halves 2 times. And so now I have kind of a shortcut. It may not be less complicated, but it's kind of a shortcut. If I square 3 halves, that's going to be the same as 3 squared, which is 9, over 2 squared, which is 4. So I have negative 14 thirds times 9 fourths. I could just go ahead and bang this out, and I will definitely get negative 126 over 12. But I'm going to go ahead and do my job here, which is to reduce the fraction. This is a shortcut that you can use to reduce fractions. I'm going to notice that 14 and 4 are both even, so I'm going to divide them both by 2. This is 7. 4 divided by 2 is 2. 9 and 3 are both divisible by 3, so I'm going to divide 9 by 3 and 3 by 3. And now we'll multiply across. 7 times 3 is 21. 1 times 2 is 2. And so negative 126 divided by 12 is the same as 21 over 2. It looks like they're both divisible by 6 in that case. So this should be, if I add that negative sign from right here, the answer to the sequence. And so we'll try one more or two more after this, but I'm going to go ahead and type that answer in here. I've got negative 21 over 2. And so we'll look at the next one here. I'm going to leave this space down at the bottom for you to write the summary, but I'm going to jump back up here. I'm going to write, how do you read sequence notation? Because that's what we talked about here, and that's an interpretation of how to read this AI thing and A1 thing. I'm going to, like, how, let's put it this way. What do we need to shortcut? And then how do you use oops, I'm getting kind of confused in my writing here. How do you use exponents to shortcut? Okay, so I'll leave this area here for you to summarize later, what you need to fill in on your own. I'm going to go ahead and work a couple of example problems. So this is example 1. So the next one is AI equals negative 6 and AI equals negative 1/3 AI minus 1. So there's really two important pieces of information here. It's this guy and this guy. And I'm looking for A2 equals what? So I'm going to notice that since A1 is negative 6, my sequence is going to start at negative 6. This bit right here tells me that I'm multiplying by negative 1/3. And then I ask the question, how many times do I need to multiply by negative 1/3 in order to get to A2? I need to go one less than the term of the sequence, or the number of the sequence, sorry, the number of the term of the sequence. So since I'm going to the second term, I just need to raise this to the first power. Negative 1/3 to the first power is just negative 1/3. Anything to the first power is itself. And so now I just multiply. Negative 6 times negative 1 is positive 6 over 3. 6 over 3 is 2, and so 2 should be my solution. Let's try one more. Good, this one's a little bit more complicated. Here is example 2. A1 equals 16/3. AI equals 3 halves. AI minus 1. I'm going to pull out the important information. It starts at 16/3, and then it multiplies by 3/2 each time. So to get to A5, I need to start at the number 16/3, multiply it by 3/2. And how many times do I have to multiply by 3/2 to get to the fifth term? It's one less than the number of the term, so it would have to be 4 times. Okay, so now I can do a bit of work. I'm going to show you the long root and then a shortcut here for working with exponents. So I can do 16/3. I can do 3 times 3 to the 4th over 2 to the 4th. 16/3 then is times 3 to the 4th is 81. 2 to the 4th I believe is 16. Then I'll notice that 16s cancel. 3 and 81 are both divisible by 3. And so 81 divided by 3 is 27. So the final answer here is 27, which should be correct. There's a shortcut you can use here. If you get 16 over 3 times 3 to the 4th over 2 to the 4th, what you can notice is that this is 3 to the 1st. And so 1, 3 will cancel with 1, 3 up here. So this is the same as 16 over 2 times 3 to the 3rd. 2 to the 4th. If you're clever enough, you can also notice that 16 is 2 to the 4th, and so these just cancel out as well. And so you just get 3 to the 3rd, which is 27. You can do it either way, but if you get really good with these exponents, you can cut out a lot of the work and cut down on the number of calculations you have to do. If you need help with any of this stuff, of course, ask, but I'm going to require that I see your notes first, so please make sure that you've copied this down and that you've made some valid